Okay, so we are going to do Chapter 6, Activity 2, Reducing Sugars. So whenever you're looking at reducing sugars, you have to kind of remember your little rules, right? Oil, rig, right? So oxidation is loss of electrons, reduction is gain of electrons, and then also in oxidation, we have a gain of oxygen and we have a loss of hydrogen, whereas in reduction, we have a gain of hydrogen, loss of oxygen. Any of these three would fit. So when we look at glucose, there are a lot of times where we want to be able to quantify the amount of glucose, sometimes quantify the amount of glucose in someone's bloodstream, right? If they're diabetic, we need to be able to quantify that. And so we use an oxidation reduction reaction in order to do that. So if we look here, we have D-glucose. So we can react D-glucose with copper, and this is Benedict's reagent, and it will actually react with the carbon. So if you look here in this molecule, you see the highlighted blue. This is the carbon that is going to become the anomeric carbon, right? And so if you look at it in D-glucose, and then you look at it after this oxidation reaction, what we see is that this is the same carbon, and what was bound to it was hydrogen, and now we have a hydroxyl. So it has, as we go this way, it has gained, I-N-E-D, gained an oxygen, and gaining oxygen is oxidation, right? So our glucose molecule underwent oxidation. If you look at the other substance, right, we started out with Cu2 plus, and we ended up with Cu2O. So what happened here? Well, see the oxygen here? The oxygen here was picked up, number one, by the sugar, and it was picked up by the copper. So the question is, what happened to copper? If we started out with Cu2 plus, and then what happens as we go here to Cu2O? What happened to that charge? Well, here you have to do the reverse crossover, right? So that really we have a 1 there. And so we're going to do the reverse crossover, and we're going to take that 2 and make that -2, and the 1 make it -1. So if we look on the periodic table, we know oxygen does have a charge of -2, so that works. And so what we can say is the copper here is where did I say minus? It's a +1, and this oxygen is a -2. So our copper is going to be positive. It's a metal, it has to be positive, right? So if we go from being a +2 to being a +1, what happened? That means that we must have gained an electron, right? Because the charge went down. So what happened to copper was a reduction. That's why we call these oxidation reduction reactions, because one substance is being oxidized, one substance is being reduced. So is D-glucose undergoing oxidation or reduction? It is undergoing oxidation. And is copper 2 undergoing oxidation or reduction? It is undergoing reduction. So all sugars that have a free anomeric carbon, that's anomeric carbon that is not participating in a glycosidic bond, are called reducing sugars, because they can undergo this reaction. They can reduce Cu2 plus to Cu1 plus. So this is a good way for us to be able to test. So is glucose a reducing sugar? Absolutely it is. So let's look at some examples, right? Locate all anomeric carbons on the following carbohydrates. So remember, anomeric carbons are carbons bonded to 2 oxygens. So 2 oxygens, that has to be anomeric. 1 oxygen here, 1 oxygen here. This one's anomeric. Let's see, 1 oxygen, 1 oxygen, anomeric. 1 oxygen, 1 oxygen, anomeric. 1 oxygen, 1 oxygen, anomeric. 1 oxygen, another oxygen, anomeric. Okay, so if you look at these, the question is, which ones are free? And this will tell you which of the carbohydrates are reducing sugars, which is number 4. We have to identify by definition, based on the definition. So do you have a free anomeric carbon, which is not in a glycosidic bond? Okay, so we look at the first one. Right there, that carbon is not participating in a glycosidic bond, so it is free. This one is free. Look at D-fructose. Again, it's a free anomeric carbon. So all monosaccharides are reducing sugars. So we would come down here and we would say, okay, well, alpha D glucose is a reducing sugar, beta D fructose, I'm just writing these names here and here, is a reducing sugar. Now I got to look at the next two. I have D lactose and D sucrose. So this glycosidic bond here, this anomeric carbon is participating in the glycosidic bond, so it's not free. So this one is a no. But this one is free. So this disaccharide is a reducing sugar. So I'm going to add it to my list. D lactose. If I look at sucrose, here's an anomeric and here's an anomeric. They are both participating in the glycosidic bond. So neither one is free. So this would be no, and this would be no. It would be a non-reducing sugar, right? Okay. Are the following carbohydrates reducing sugars? Well, if I look at A and I look at B, these are both monosaccharides. So yes, those are. So monosaccharides. So A and B are reducing sugars. I look at lactose and maltose. So I came up here and I looked at lactose, right? So that's C. C is right there. What do we say about lactose? Yes, it's a disaccharide. So you could put that, it's a disaccharide, but it is a reducing sugar because it has a free anomeric carbon. Maltose, I'm trying to think if we had maltose. I think maltose is not on here. So if you go from maltose, in our first activity, so in table 1, on page 2 of our first activity, so up here, we go up here, right? Here we have D-maltose. So if we look at D-maltose, here's an oxygen, there's an anomeric, here's an oxygen, there's an anomeric. So this one is no, not free, but this one is free. So that makes D-maltose, if we come all the way down again, D-maltose of, let's see, first activity. That makes D-maltose, yes, it is a disaccharide, but it is reducing. Now, the last two, cellulose and starch, they're very similar. Both cellulose and starch are polysaccharides. Now, these polysaccharides are super long. So they have glucose unit after glucose unit after glucose unit, right? You would draw this chain and you would just keep drawing the chain and it would be thousands of glucose units long. And so if you look at one of these sugars, what you're going to see is that the anomeric carbon is going to participate in one of the bonds, but the other anomeric carbon is not. So at the very end, you'll have one free anomeric carbon. But if I want to use this to quantify the amount of sugar there, it's not going to be a real measurement of how much cellulose or how much starch I have, because you're only going to be measuring one when you have this chain here that's going to be thousands. It's very long. So thousands of glucose units, right? So even though one end is technically reducing, we call these polysaccharides non-reducing because just measuring one free end doesn't actually tell you how much cellulose is there. It just tells you how many ends you have, which is very, very few compared with how long and how big starch and cellulose are. So it's just not a very good measurement. So we say no, those are not. Okay, ribitol found in a vitamin riboflavin is formed from D-ribose. The reaction shown below. Is the reaction oxidation or reduction? So if I look at what's happening, right? something's happening with that anomeric carbon. Well, what's going to become the anomeric carbon? So this one right here. And sometimes it might be nice for you to go ahead and draw out this CH2OH. What does that actually mean? Well, it means that carbon's bound to a hydroxide, and I'm going to just kind of draw over this. It's bound to a hydrogen on this side and a hydrogen on that side. So if we look, the first carbon here is only bound to one hydrogen and one oxygen. If I look here, 1, 2 hydrogens, and that oxygen picked up a hydrogen. So if we are adding hydrogens, that must mean that we are undergoing reduction. Okay, and that's it.